NENOMATICA, where mathematics meets YouTube excellence. Welcome to this tutorial on expanding and simplifying algebraic expressions. Today we'll walk through the process of simplifying complex expressions with binomials squared. Let's start with our first example. We need to expand and simplify the expression 3 times the quantity a minus 1 squared minus 2 times the quantity a plus 3 squared. Our first step is to expand each of the squared binomials using the formula for the square of a binomial. The square of a binomial a plus b is equal to a squared plus 2ab plus b squared. Similarly, the square of a binomial a minus b is equal to a squared minus 2ab plus b squared. Now let's multiply the terms inside each pair of parentheses. For the first term, we have a times plus a times negative 1 plus negative 1 times a plus negative 1 times negative 1. For the second term, we have a times a plus a times 3 plus 3 times a plus 3 times 3. Let's simplify these multiplications. In the first expression, we get a squared minus a plus 1. In the second expression, we get a squared plus 3 a plus 3 a plus 9. Next, we combine like terms within each parenthesis. In the first expression, negative a minus gives us negative 2a. In the second expression, 3a plus 3 gives us 6a. Now we distribute the coefficients through each parenthesis. For the first term, we multiply each term inside the parenthesis by 3, giving us 3 a squared minus 6 a plus 3. For the second term, we multiply each term inside the parenthesis by negative 2, giving us negative 2 a squared minus 12 a minus 18. Let's group like terms to make our final simplification easier. We group the a squared terms, the a terms, and the constant terms. Finally, we combine like terms to get our simplified expression. 3a squared minus 2a squared gives us a squared. Negative 6 a minus 12 gives us negative 18a. 3 minus 18 gives us negative 15. So our final answer is a squared minus 18 a minus 15. Let's move on to our second example. Here we need to expand and simplify 2x cubed minus 2 times the quantity x plus 1 times the quantity x squared minus x plus 1. First, let's multiply the binomial x plus 1 by the trinomial x squared minus x plus 1. We'll use the distributive property, multiplying each term of the trinomial by each term of the binomial. Now, let's simplify these multiplications. X times x squared gives us x cubed. X times negative x gives us negative x squared. X times 1 gives us x. 1 times x squared gives us x squared. 1 times negative x gives us negative x. 1 times 1 gives us 1. Let's combine like terms inside the brackets. We have x cubed. The x squared terms cancel out because we have negative x squared plus x squared. The x terms cancel out because we have x minus x. And we have the constant term 1. Now, we distribute the coefficient negative 2 through the bracket. Negative 2 times x cubed gives us negative 2x cubed. Negative 2 times 1 gives us negative 2. Finally, we combine like terms to get our simplified expression. 2x cubed minus 2x cubed equals 0. So we're left with negative 2. We'll expand the expression 2x minus 3 times x minus 2 squared. First, let's expand the squared term x minus 2 squared. To do this, we'll use the formula for the square of a binomial. A minus b squared equals a squared minus 2 a plus b squared. This gives us 2x minus 3 times x minus 2 times x minus 2. Now, let's continue with our expansion. We'll use the distributive property to multiply the binomials. So we get 2x minus 3 times x plus x times negative 2 plus negative 2 times x plus negative 2 times negative 2. Simplifying, this gives us 2x minus 3 times x squared minus 2x plus 4, which further simplifies to 2x minus 3 times x squared minus 4x plus 4. Now we need to multiply 2x minus 3 and x squared minus 4x plus 4. We'll use the distributive property again. This means we multiply each term in the first bracket by each term in the second bracket. So we have 2x times x squared plus 2x times negative 4x plus 2x times 4 plus negative 3 times x squared plus negative 3 times negative 4x plus negative 3 times 4. This simplifies to 2x cubed minus 8x squared plus 8x minus 3x squared plus 12x minus 12. Finally, we combine like terms. Let's group terms with the same power of x. We have 2x cubed minus 8x squared plus 3x squared plus 8x plus 12x minus 12. This gives us 2x cubed minus 11x squared plus 20x minus 12. So our final answer is 2x cubed minus 11x squared plus 20x minus 12. Let's now look at another example. This time, we'll expand the expression 2a minus 3b times 3a plus 2b minus 6 times a minus b squared over a minus 5b times a. Let's first focus on expanding the first part of our expression, 2a minus 3b times 3a plus 2b. We'll use the distributive property to multiply these binomials, multiplying each term in the first bracket with each term in the second bracket. 2a times 3a plus 2a times 2b plus negative 3b times 3 plus negative 3b times 2b. This simplifies to 6a squared plus 4 of minus 9 of minus 6b squared. Combining like terms, 6a squared minus 5 of minus 6b squared. Now, let's expand the second part of our expression. 6 times a minus b squared over a minus 5b times a. We'll distribute the multiplication. This gives us 6 times a minus 6 times a times b squared over a minus 6 times a times 5b. Simplifying, 6a squared minus 6b squared minus 30 up. Now, we can combine both parts of our expression. We need to subtract the second expression from the first. We have 6a squared minus 5 of minus 6b squared minus 6a squared minus 6b squared minus 30 up. Let's rearrange and group like terms. 6a squared minus 6a squared plus negative 5 of minus negative 30 up plus negative 6b squared minus negative 6b squared. Simplifying, 0 plus negative 5 up plus 30 up plus 0. This gives us 25 up. So our final answer is 25 up. Let's summarize what we've learned. When expanding algebraic expressions, we have a to the fourth minus 2a squared, all raised to the power of 3. Our first step is to understand what this power means. When we have a quantity raised to the power of 3, we're multiplying that quantity by itself 3 times. So we can rewrite our expression as a product of 3 identical factors. Now, let's multiply the first 2 factors. We'll use the distributive property, multiplying each term in the first factor by each term in the second factor. This is similar to applying the FOIL method, but with more terms. Let's simplify the products in the first parentheses. When we multiply a to the fourth power by a to the fourth power, we get a to the eighth. When we multiply a to the fourth by negative 2a squared, we get negative 2a to the sixth. When we multiply negative 2a squared by a to the fourth, we again get negative 2a to the sixth. And finally, when we multiply negative 2a squared by negative 2a squared, we get positive 4a to the fourth. Next, we can combine the like terms in the first parentheses. We have negative 2a to the sixth twice, which gives us negative 4a to the sixth. So our expression simplifies to a to the eighth minus 4a to the sixth plus 4a to the fourth, all multiplied by the third factor, a to the fourth minus 2a squared. Now, we'll multiply our intermediate result by the third factor. Again, we'll use the distributive property, multiplying each term in the first parentheses by each term in the second parentheses. Let's simplify each of these products using the laws of exponents. When we multiply a to the eighth by a to the fourth, we get a to the 12th. When we multiply a to the eighth by negative 2a squared, we get negative 2a to the 10th. For the remaining terms, we multiply negative 4a to the sixth by a to the fourth to get negative 4a to the 10th. Then we multiply negative 4a to the sixth by negative 2a squared to get positive 8a to the eighth. Next, we multiply 4a to the fourth by a to the fourth to get 4a to the eighth. Finally, we multiply 4a to the fourth by negative 2a squared to get negative 8a to the sixth. For our final step, we'll combine the like terms in our expansion. We have a to the 12th as is, then we have negative 2a to the 10th and negative 4a to the 10th, which gives us negative 6a to the 10th. Next, we have 8a to the 8th and 4a to the 8th, which gives us 12a to the 8th. Finally, we have negative 8a to the 6th. So our final answer is a to the 12th minus 6 a to the 10th plus 12a to the 8th minus 8a to the 6th. Our goal is to simplify this complex expression step by step. Let's simplify this expression one term at a time. First, let's focus on the middle term. We have 7a to the 4th power b to the 6th power times 2a to the 6th power b to the 4th power. Using the product rule of exponents, when we multiply terms with the same base, we add the exponents. So for the variable a, we add exponents 4 plus 6, which gives us a to the 10th power. For the variable b, we add exponents 6 plus 4, which gives us b to the 10th power. And we multiply the coefficients 7 times 2 to get 14. Now, let's simplify the third term. We have 3a to the 5th power b to the 5th power, all squared. Using the power rule of exponents, when we raise a term to a power, we multiply the exponents. So for the variable a, we multiply exponent 5 by 2, giving us a to the 10th power. For the variable b, we multiply exponent 5 by 2, giving us b to the 10th power. And for the coefficient 3, we square it to get 9. Now that we've simplified all the individual terms, we can see that all three terms have the same variables with the same exponents, a to the 10th power b to the 10th power. When terms have the same variables with the same exponents, we can combine them by adding or subtracting their coefficients. So we have 110 plus 14 minus 9. Let's calculate 110 plus 14, which gives us 124. Then 124 minus 9 gives us 115. So our final simplified expression is 115a to the 10th power b to the 10th power. Now, let's tackle a more complex example. Here we have the square of 5a to the 5th power b to the 4th power c to the 3rd power times the cube of 10a to the 3rd power b to the 4th power c squared minus 5,000 a to the 19th power b to the 20th power c to the 12th power. Let's simplify this step by step using the same rules of exponents we learned earlier. Let's start by applying the power rule to the first term. 5a to the 5th power b to the 4th power c to the 3rd power, all squared. When we raise a term to a power, we multiply the exponents by that power. For the coefficient 5, we square it to get 25. For the variable a, we multiply exponent 5 by 2, giving us a to the 10th power. For the variable b, we multiply exponent 4 by 2, giving us b to the 8th power. For the variable c, we multiply exponent 3 by 2, giving us c to the 6th power. Now, let's apply the power rule to the second term. 10a to the 3rd power b to the 4th power c squared, all cubed. For the coefficient 10, we cube it to get 1,000. For the variable a, we multiply exponent 3 by 3, giving us a to the 9th power. For the variable b, we multiply exponent 4 by 3, giving us b to the 12th power. For the variable c, we multiply exponent 2 by 3, giving us c to the 6th power. Now, let's multiply the first two terms together. When multiplying terms with the same variables, we add their exponents. For the coefficients, we multiply 25 by 1,000 to get 25,000. For the variable a, we add exponents 10 plus 9, giving us a to the 19th power. For the variable b, we add exponents 8 plus 12, giving us b to the 20th power. For the variable c, we add exponents 6 plus 6, giving us c to the 12th power. Finally, we can combine like terms since both terms have the same variables with the same exponents. We have 25,000 minus 5,000, which gives us 20,000. So our final simplified expression is 20,000 a to the 19th power b to the 20th power c to the 12th power. Let's summarize the key rules we use to simplify these expressions. First, the product rule of exponents. When multiplying terms with the same base, we add the exponents. Second, the power rule of exponents. When raising a term to a power, we multiply the exponents by that power. And third, we combine like terms by adding or subtracting their coefficients when the variable parts are identical. By applying these rules systematically, we can simplify even complex algebraic expressions. Remember to always look for opportunities to apply these rules when simplifying algebraic expressions. Practice is key to becoming proficient. Thank you for watching this tutorial on simplifying algebraic expressions. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.